Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. This video is to presenting a mini project for performing optimization and production line. Before that, my name is Muhammad Yusof bin FUZI and my colleague is HAZIQ bin HISHAM RAZUL. For introduction, the objective is to analyze and optimize the efficiency of the PCB production line at Neo Electronics Berhad. The scope is, first of all, performing theoretical calculation for current production line performance. Second, develop a simulation model to compare with the theoretical calculation. Third is identify problem and propose solution to improve the performance. And lastly, design and simulate a new production line with optimization methods. For theoretical performance calculation, first of all, a second dimension, we can see for panel 1 and panel 2, 0.7 minute per panel and plus 0.1 minute to set up. As you can see for expectation minimum is 0.5. So the production rate is 90 panel per hour. For SM machine, site 1 for site 1 is 150 panel per hour and site 2 is 100 panel per hour. For output analysis, daily output for 8-hour shift in a good product is 1140 panels per day, and defect rate is around 50% for inspection and 1 or 2% for inspection 2. And monthly output for 20 working day is 18,240 for good panel. So the current production line simulation is simulation results. The total part created is 30,131 panel by using max labor at 99.71%, and the conveyor is at 0.52%. For performing insight, frequent breakdown in estimation reduced through. And second, conveyor and buffer are underutilizing or causing bottleneck. Comparing with theoretical result, simulation to output match theoretical estimate that in 30,131 panel. Second, minor disruption due to real-time delay in machine breakdown and repair. For next slide, I will pass to my colleague to explain it.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAZIQ bin HISHAM, and I'll continue this slide with problem analysis. There are three identified issues that has occurred during our simulation. The first is the frequent machine failures of the breakdown of the SM and S-print machine. Then the underperforming inspection of the inspect 1 machine that has detected a rate of 5%, which is higher than desired. Next is the limited conveyor and buffer capacity that has occurred delays due to its inefficient handling capacity. The impact of this production is that the output is reduced due to the machine's downtime and defects, and operational inefficiencies results in increased costs and delays in meeting sales orders. The suggested improvements include adding a new SM machine that will reduce the bottleneck in chip placement, which will cost around 30,000 ringgit. Then next is to upgrade the S-print machines, which will reduce the cycle time by 10%, which will cost around 5,000 ringgit. Next is to increase the oven capacity, which will add the capacity to handle more panels, which will cost around 10,000 ringgit. And finally is to improve the conveyor and buffer capacities, enhancing them by 20%, which will cost around 10,000 ringgit. So in total of the improvements is around 55,000 ringgit out of the 10,000 ringgit budget for improvements. The expected improvements is around 15% increase in output, and they reduce defect rates by optimizing the inspections. The new manufacturing plant study key features of the new models are the addition of an SM machine that will improve the chip placement and become the machine will become more accurate. Enhancing the sprint and flip machines will reduce the cycle time, and increasing the oven and buffer capacities to prevent any more delays. The performance summary is that the top will be increased to around 16,000 panels per month. The defect rate is really reduced by to an average of 3%, and the utilization of the balance across all machines and minimizing downtime. Here shows the differences between the output, defect rate, and efficiency of the current model and the improved model, which will show that the improved model will has a higher output of panels, lower defect rate, and higher efficiency. That's all from me. And the conclusion of the our presentation is that the improved model resulted in a 22,000 increase in output, and defect rates were reduced by 40%, improving overall quality. The machine utilization and efficiency were significantly balanced, and the recommendations is to implement the optimized model for full-scale production and the regularly monitored machines performance to sustain efficiency. Thank you for listening.